solve the following logarithmic equation. Log x squared minus 6x to base 2 is equals to 3 plus log 1 minus x to base 2, isn't it? So the first thing, as usual, we must ensure we have the same base all through. Use the laws of logarithm. So here we have base 2 meaning this term must also have log to base 2, isn't it?
Yes.
So we are going to have log x squared minus 6x to base 2 is equals to 3. Now this term of 3, we introduce log 2 to base 2. A log of a number to the same base is 1. So we now have base 2 all through, isn't it?
Yes.
The last term there we had log 1 minus x to base 2. So we have base 2 in this term, base 2 in this term, base 2 in that term, isn't it?
Yes.
So the next step is to get rid of the coefficient, isn't it?
Yes.
So if you get rid of the coefficient, this side will have log x squared minus 6x to base 2 to be equal to this 3, it will become the power, isn't it? So we get log 2 raised to power 3 to base 2 plus log 1 minus x to base 2. Then after getting rid of the coefficient, what do? A single term on both sides, isn't it? So this side we already have a single term, that is log 2 base 2 of x squared minus 6x, isn't it? Then you can see 2 cubed is 8, isn't it? So you see we are going to have a single term. Here it means when you factorize out log 2 base 2, inside you are going to remain with 2 cubed. This is addition, it goes back to multiplication, isn't it? So it is 2 cubed times 1 minus x, isn't it?
Yes.
So that when you take the log back inside, this multiplication goes back to addition, isn't it? Are we together? So you know we now have log 2 base 2 of x squared minus 6x is the same as log 2 base 2 of what? 2 raised to power 3 is 8, isn't it?
Yes.
8 multiplies everything inside this smaller bracket, isn't it?
Yes.
8 times 1 is 8, 8 times x is 8x, isn't it? After that, you ignore the logs on either side of the equation because it is now single term, isn't it?
Yes.
So if you ignore log 2 base 2 here, you remain with x squared minus 6x is equals to 8 minus 8x. Then you collect the like terms, isn't it? So here we have x squared minus 8 coming this side is plus 8, isn't it? So plus 8 minus 6x, you remain with plus 2. Plus 2x, isn't it? Then positive 8 coming this side is minus 8 to be equals to 0, isn't it? So what are the solutions of x here? If you use the quadratic formula, you see a product of negative 8 and a sum of positive 2. See, that is negative 4 and 2, isn't it?
Yes.
Negative 4 and 2. So what are going to be the solutions of x? Go to the calculator and get me the solutions of x. Meaning you are going to have x squared minus, it is positive 4 negative, positive 4x and negative 2, isn't it?
Yes.
So plus 4x minus 2x minus 8. So if you do that, you get x into x plus 4, then minus 2 into x plus 4. So it is x minus 2 and x plus 4 to be equals to 0. So either the first term, which is x minus 2, which is 0, or the second term, which is x plus 4, which is 0. So if you solve the first case here, you get x is equals to 2, isn't it? If you solve the second case here, you get x is equals to negative 4. But you see, these logarithms were not having absolute value, so you ignore the negative solution. Are you seeing? So in the end, you get your solution of x to be equals to 2. Are we together there? So we have finally the solution of x is equals to 2. You ignore the negative solution because we don't have the absolute values there. Okay? Good. Let us go.